Just a brief discussion about inequalities and logs, especially when it comes to GPs. Okay, so first thing about inequalities, let's choose something like 5. We know 5 is bigger than 2. If we times that by minus 1, then the inequality is no longer true. Minus 5 is bigger than 2, but minus 5 is not bigger than minus 2. The size is bigger, but minus 5 is a smaller number than minus 2. So when we times by minus 1, we need to turn this round. The reason for that is if we start off with 5 is bigger than 2, if we take away 5 from both sides, then 5 take away 5 is 0, and that's bigger than 2 take away 5, which is minus 3. If now we take away 2 from both sides, then 0 take away 2, which is minus 2, is still bigger than minus 3 take away 2, which is minus 5. So that's the reason why we have to turn this sign round. We also do it for a similar reason. If we start off again with 5 is bigger than 2, if we do 1 over as our function, so we find the reciprocal, then 1 over 5 is not bigger than 1 over 2. A half is bigger than a fifth. So again, we need to change the symbol round. And the reason for that, similar to this one, is if we start off with 5 is bigger than 2, and we divide both sides by 5, then 1 is still bigger than 2/5. So there's divide by 5. If now we divide by 2, then a half is still bigger than 2/10. So that's divided by 2. So this is true, which is why we need to turn that round. And of course 2/10 is a fifth. Okay, so if I've got a situation where I've got log or x log of a fifth is bigger than 3 log of 2, then the next we could do that, of course, that's the same, equals log of 8, any base, it doesn't matter. Then if we do divide both sides by log of any base of a fifth, and we divide that side by log any base of a fifth, obviously these bases are the same, then x is not bigger than log 8 over log a fifth, because log of a fifth is less than 0. And so what we're doing is, instead of times by minus 1 as we do up there, this is the same as if we divide by minus 1. So if we divide by a negative, the inequality thing, we have to think about this situation. Let's have a go at that. If I do 5 divided by minus 2, start off with 5 is bigger than 2, divide by minus 2 is not bigger than 2 divided by minus 2, because this is minus 2.5, and that's not bigger than minus 1. This is a smaller number. So for the same reason we discussed in here, when we divide by a number that's negative, we need to change our inequality sign. We can understand which logs give us a negative by thinking about the log graph. So we know what y is equal to something to the power of x is. That graph looks like this one that goes through 0, 1, sorry. To get to the inverse of a to the power of x function, we reflect this graph in the line y equals x. And when we reflect that graph, that's not a bad reflection, Steph, well done. Then we get y equals log base a of x. And this point will be 1, 0. So if we choose an x value up here, x is equal to, I don't know, 2.1, then the y value, which is log base a of 2.1, is bigger than 0, look. So that will be the same, obviously not the same value, but it will still be positive if we choose any x value where x is bigger than 1. When we do log of 1, we always get 0, any base. When we choose x is, I don't know, 0.53, and we log any base of 0.53, because this number is between 0 and 1, then the y value will be log of 0.53, any base, and that will be less than 0. And we can see that if I choose a random log, I don't know, 2.356 as a base minus 0.53. I can't do minus one. Nah. Log 2.356 of 0.53 is minus 0.74. So we get minus, and you can try this number as any fraction. What happened originally was I tried a value of x which was less than 0, and that's the standard mistake that people make. So log of a number that's between 0, choose a number that's between 0 and 1, take the log of it. So log base a of x is less than 0 if or when 0 is less than x is less than 1. So when x is a fraction, the log of a fraction will be negative.